Welcome to the deep dive. Today, we're embarking on a really crucial journey. We're going high above the clouds and then right down into the nitty-gritty, the meticulous choreography of aircraft, both on the ground and, in the air, right around the airport. And look, this isn't just abstract theory. This is absolute vital knowledge if you're prepping for your ATPL exams. And frankly, it's fundamental for your entire future career in aviation. So our mission today, we've got this stack of sources covering aircraft control, everything from the old school procedural ATC right up to modern radar systems and, yeah, those critical emergency protocols that keep everyone safe up there. We're going to distill the absolute most important nuggets of knowledge, the stuff that's really going to help you ace those ATPL theory exams. Think of it as your, express lane to understanding that intricate dance of planes in our skies.
Exactly. And our goal here is to break down these sometimes quite complex procedures into insights you can actually grasp. We want you to understand not just what happens, but crucially, why it matters. It's about connecting the dots, right? Building a really robust understanding. We'll be focusing hard on key concepts that directly tackle common exam questions, so you feel truly well-equipped.
Perfect. So settle in, listen closely. We're about to uncover some really essential takeaways, maybe even a few surprising facts, stuff that's definitely going to be key for your exam success. Let's dive in.
Okay, let's unpack this. Before we get into the really detailed stuff about modern ATC, it's fascinating to look at how it all began. It's almost hard to imagine now, but skies used to be, well, a bit of a free-for-all. What really pushed the creation of air traffic control, this whole intricate system we rely on now, was actually a pretty grim reality, high collision rates, especially right after World War II. That's right. It was a system born out of, well, necessity bordering on chaos. Our sources trace the concept right back to that critical, desperate need for safety. After World War II, things got a lot busier, particularly around aerodromes. And with that came, a grim picture. High loss rates.
High loss rates, meaning
We're talking mid-air collisions near airports, aircraft hitting obstacles on or near the ground, even pilots inadvertently flying into terrain because they just didn't know where they were relative to obstacles or other aircraft. It was clear something had to change. Order was needed.
Wow. So it wasn't just about the immediate airport runway.
No, exactly. Beyond the immediate boundary, what we now generally call the ATZ, the Aerodrome Traffic Zone, that protected bubble right around the airport, there was very little active control initially. What you had was this very rudimentary flight following service, basically a simple check to see if an aircraft was still, airborne once it left the vicinity.
Super basic then.
Incredibly simple, often just relied on infrequent reports, minimal real-time control. The focus wasn't really on active separation, more just knowing if a plane was still up there. The real catalyst, the moment that really hammered home the need for a more structured system, was in the early 1950s.
Ah, the Grand Canyon incident?
That's the one. Two constellations colliding over this vast empty space. Two relatively small objects. It was a tragedy, but it starkly highlighted the inadequacy of the existing setup. It led directly to the establishment of the first proper procedural ATC service. Revolutionary at the time.
A huge leap, definitely. So how did this early procedural ATC actually work? It sounds complex without modern tech. Lots of manual work.
Oh, absolutely. It was essentially a manual ballet. Human diligence was the main separation tool. Procedural ATC initially worked by requiring aircraft at the same altitude to fly different routes. Lateral geographic separation.
Like invisible highways?
Kind of, yeah. Or one-way systems, like our source mentions for the continental U.S. back then. East-west traffic on different tracks. The whole thing hinged on pilots radioing in their position. The ATCO's air traffic control officers, they'd take that data, plot it manually, often on paper charts, and track the flight's progress. They'd then try to figure out if there was any collision risk down the line.
And if there was.
If they saw a potential conflict, they'd radio the flights involved and ask them to alter course, change heading, maybe change altitude to eliminate the threat. But the challenges were huge, looking back. The equipment for figuring out an aircraft's position, pretty crude. Communications gear.
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best,